Hello everyone, my name is Nikhil Hugar. I am from New Horizon College of Engineering. I'm pursuing my electronics and communication engineering, and I've been chosen from Emertxe Information Technologies for an internship on embedded systems. And I'm doing this project along with Ujjwal and Veda. Ujjwal, can you introduce yourself?
Myself Ujjwal, and I am from NMAMIT Institute of Technology, and I am currently in final year pursuing electronics and communication.
Okay, Veda, please introduce yourself.
Yeah, hello everyone. I am Vyas Alpuri. I am pursuing my final year undergraduate from Sree Vidyanikethan Engineering College, Tirupati, from the Department of ECE. I have been very glad to perform this internship with the team along with Nikhil and Ujjwal. From here, my friends will carry out the rest. Thank you.
Thank you for your introduction, guys. Now, I would like Ujjwal to start off with the introduction.
Coming to the introduction part, um, embedded systems play a vital role in shaping the modern technological landscape, serving as the cornerstone of innovation in various domains, from powering everyday devices like smartphones and wearables to controlling critical infrastructure in automotive and aerospace industries. Embedded systems have become an indispensable component of our interconnected world. This introduction provides a foundational overview of embedded systems and sets the stage for exploring the enriching experience of an internship focused on dynamic fields. Embedded systems are specialized computing systems designed to perform specific tasks within a larger system or devices. Unlike general-purpose computers, which are versatile and adaptable, embedded systems are optimized for efficiency, reliability, and real-time operation. They typically consist of combination of hardware components such as microcontrollers or microprocessors and software tailored to meet the requirements of the application research. Coming to the overview of embedded C, firstly, we went across the basic data types that are used in embedded C, that are character, integer, float, and double. We came across modifiers such as long, short, signed, and we also came across conditional constructs that are classified into two types, such as single iteration and multi-iteration. Single iteration constructs include if and if is family, switch case, whereas multi-iteration constructs include for, while loop, and do while. Next comes operators. We went across various kinds of operators used in embedded C that are arithmetic, logical, relational, assignment, bitwise, and size of operator. It also includes ternary operators, uh, and we came across arrays, which is a collection of data of same data type. We went across reading, storing, and initializing and copying the array content. So coming to pointers, pointers contain the address of a variable, little endian and big endian. We also came across null pointer, which is pointing to nothing, and we came across function which performs a specific service and is reusable code. So we also came across pass by value and pass by reference, which is used in the function, and a function which is called itself is called a recursive function. Next, we came across strings, which is a continuous sequence of characters. We also came across library functions such as string length, string copy, string concatenation. Storage class, the Linux operating system is divided into two major sections, the user and the kernel space. So the examples include auto registry, static local, static global, and external. The memory segments of a program contains four major areas that are test segment, stack segment, data segment, and heap segment. So we also came across preprocessor directors that mainly contains header files. So header files are nothing but a file containing C declarations and macro definitions to be shared between several source files using a preprocessor directive. So coming to the overview of microcontroller, a integrated circuit which is capable of performing to perform a specific task is called uh, microcontroller. In microprocessor, all the components are separated. Uh, they are not present in single chip, whereas in microcontroller, all the components can be present in a single chip. Embedded system is a combination of hardware and software components which is intended to do a specific task. So the embedded system can be broadly classified into four major categories that are standalone embedded system, real-time embedded system, network embedded system, and mobile components embedded system. The requirements of embedded systems include the challenges and real-time aspects in embedded systems. So next we came across interfacing of LEDs, the working principle, and the circuit on board. Interfacing of digital keypad, we came across tactile switches, bouncing effects, circuit on board, triggering methods such as level triggering and edge triggering. We also came across interrupts that are an external or internal device request, the microprocessor that is sent to a microprocessor in order to stop the processing. We came across classification and handling of interrupts, and we also came across service routine such as interrupt service request, which is similar to a subroutine where a microcontroller attempts to request an interrupting source. The interfacing of timers. We went across resolution, register with pickup count or down count, quantum system clocking settings, and pre or post scaling. Interfacing of clock input and output. Uh, we came across interfacing input and output peripherals. Uh, so the analog inputs, that is ADC, which stands for analog to digital converter, and digital outputs using that, that is digital to analog converter. We came across interfacing of SSDs and character liquid crystal displays, which is most commonly used to display the ASCII character. So the communication modes of microcontroller include 4-bit mode and 8-bit mode. So next it will be told by my friend Veda.
Okay,
Yeah,
thank you,
thanks.
Ujjwal.
Yeah, I'll be stating the problem statement and purpose of my project. Coming to the problem statement is about designing and development of washing machines, which are complex process that require meticulous testing and validation to ensure optimal performance and reliability. One crucial aspect of this process is the simulation of washing machine functionality, which allows engineers to access the efficiency of control algorithms, sensor integration, and overall system behavior in a virtual environment before physical implementation. Coming to the purpose of the project, this project focuses on simulating a washing machine using PICSimLab, aiming to replicate real-world washing machine functionality in a virtual environment. The project begins with a comprehensive understanding of washing machine components, cycles, and operations. Parameters defining laundry status such as fabric type, load size, and water level, which are identified. Coming to the tools required, it includes majorly two tools, that is MPLAB IDE with a version of 5.35x, where we generally use to write the code in general C code with an X8 compiler developed by Microchip specifically, which is 8-bit PIC microcontroller. Coming to the tool 2, which is PICSimLab in its latest version, is a real-time emulator of development boards with MPLABX and including the debugger integration. It includes PIC board along with PIC16F877A microcontroller. The PIC16F877A microcontroller features 256 bytes of EEPROM data memory, self-programming, and an LCD. Having two comparators, 8 channels of 10-bit analog to digital converters, in short ADC, along with two capture compare PWM functions. The synchronous serial port can be configured either a 3-wire SPI or the 2-wire inter-integrated circuit. Coming to the PIC16F877A is a 40-pin DIP, that is 40-pin microcontroller designed using RISC architecture, which can be reduced instruction set cycle and is used in embedded projects. It has total 5 ports starting from port A to port E. It has 3 timers, out of which 2 timers are 8-bit timers, while 1 timer is of 16-bit. This is a basic glance of our project working, where we'll be shown in a 16 cross 4 CLCD display that power on a washing machine. We will be using 5 switches starting from RB0, RB1, RB2, RB3, RB4, and RB5, where each switch has the different functionality that my friend is going to explain it during the simulation. This is the basic architecture of PIC16F877A microcontroller having GPIO, buzzers, LEDs, digital keyboard, SSDs, matrix keyboard along with a temperature sensor called LM35 along with I2C, RTC and EEPROM peripherals. Coming to the functional requirement, we will be providing a buzzer along with motor indicating the navigation, power on, pause and stop along with door status and display washing status, which represents the various functionalities of the microcontroller programmed using PIC16F877A microcontroller. A CLCD stands for Character Liquid Crystal Displays, which comes in two sizes, either 16x2 or 16x4. It utilizes 16 interfacing lines for operation. Data transfer occurs via lines called D0 to D7. The controller executes both instructions and data. Coming to the RS line, standing for Register Select Line, determines the type of operation. If the RS value indicates 1, then data transfer is going to occur, while RS value of 0 indicates instruction execution. CLCDs can display all ASCII characters and symbols. Data processing involves two methods, mainly delay method and pole D7 method. In the pole D7 method, continuous monitoring of D7 is required while providing data on data lines. If R by W is 1, indicating the reading, while the R by W is 0 when we want to write. With R by W permanently grounded, only data writing is enabled. In CLCD setup, D0 to D7 are linked to port D, while RS and enable pins are connected to port E. Enable pin serves as an indicator signaling the LED about the start of the data transmission from the microcontroller. In matrix keyboard, we need to configure rows as output and columns as input. When designing pull-down interface, R1 is 10 times greater than R2. That is, R1 is strictly greater than 10 R2. Coming to the triggering methods, mainly edge triggered and level triggered, includes the bouncing effect as well. There is a metal plate and terminal, spurious pulsar detection while pressing and releasing the tactile switch, which can be termed as a bouncing effect. Matrix keyboards are employed when multiple user inputs are needed while conserving controller input and output lines. They utilize a grid of rows and columns, commonly found in devices like telephones, digital lockers, and calculators. In cooking mode, matrix keyboard keys are utilized to select various modes. A tactile keyboard. A key switch is considered tactile when it provides a noticeable bump or tactile feedback in response to finger pressure, typically felt at or near the point where the key press is registered before reaching the end of its travel. A keyboard is tactile if it is constructed using tactile key switches. The system features three modes: PWM or pulse generated mode, counter mode, pulse width or pulse speed measurement, etc. Coming to the including parameters, tick for up or down count, quantum for system clock setting, scaling for pre and post scaling, resolution for register width. Operational modes include micro mode and grill mode. The timer is set using a matrix keyboard with star asterisk to clear and asterisk to enter. For toggling the LED, an 8-bit resolution is necessary. Coming to the simulation of
So
project, my friend Nikhil will be continuing.
thank you, Veda. And now I will be going ahead and showing the simulation of our project. So we're using the MPLAB X IDE version 5.35. This is the interface of our software. So this is where our project loads up. And if we want to open a project that is already being done, we just go here and open up the project. And this is our project with the header files that is been placed in header files and the C files which have been placed in the source files. So now the main.c file is open here, where the timer.c file is open here. I'll be opening up this header files first, that are the CLCD one, where the code is been done, digital keypad, main.h, and timer. These are the header files that have been included. Now I will be opening up the C files. This is the CLCD for C file, the digital keypad C file, the ISR C file, the main.c file, which has the most amount of code, where the main code is being programmed in order to make the washing machine function as required by our higher authorities. And this is the timer. So after coding and implementing the project requirements, we have to clean and build. So cleaning and building is basically for checking if there are any errors in the code. As we can see, the build was successful and the loading is completed. So this gives us a sign that we can go ahead with our simulation. So we open the PICSimLab tool, which is the simulator tool. So here is the board, and we use the PIC Genesis board, and the microcontroller we'll be using is this PIC16F877A. And here, if the file is not loaded, here it's already loaded, so I'll load it again. So we find our file, the hex file. We go to dist, and in default and in production we find our hex file, which we open up, and this is where it is. And now it says press key 5 to power on the washing machine. So like Veda said, the switches are numbered as 1, that is RB0 is actually switch 1, switch 2, switch 3, switch 4 and switch 5. So RB4 is our switch 5. So I press RB4 and turn the washing machine on. Now, according to the requirements, it asks us to choose different washing programs. So here we have heavy delicate whites and delicate whites stain wash, whites stain wash eco cottons, stain wash eco cottons woolen, eco cotton woolen bed sheets, woolen bed sheets rinse plus dry, bed sheets rinse plus dry and dry only, rinse plus dry, dry only or and wash only, dry only, wash only, aqua store, wash only, aqua store and daily, and more options that have been implemented as required. And to select any option of the washing program desired by the user, we hold the switch 4, that is RB3, in order to select the option. Upon selection, we are asked to select the water level. Here it is auto, low, medium, and as such, low, medium, high, max, high, max, auto, and max, auto, low. And to again choose the option, we again select the switch 4 and hold it for a few seconds to select the option. And here we get a press switch. Either to start, we press switch 5, that is RB4, and switch 6, that is RB5 to stop. So I would want to start my washing program, so I press switch 5 and it starts the program. So this is the, now it's washing. As you can see, the fan is rotating, and it's cooling the washing machine vital. And the washing time for this particular program is 1 minute and so seconds. So we'll have to wait until the program is done. And the requirements also suggested to include a door open option, where if we press switch 1, the door is opened, and the buzzer is buzzing right now, and we close. Once we let go of the switch, it let's close the door again, and if I press it again, it will open the door and also buzz a sound. And now they've closed the door, and also the next step of the program for washing is spin. So it's at spin right now, and we have 10 seconds left for the washing machine to finish its program. And we can press pause to pause, that is switch 6, which is RB5, and to start I press 5 again and it starts. And we also get a buzz at the end stating that the program has been completed, and this is the end of the program and what we have learned from the internship. And I would like to thank Emertxe Information Technologies and Jayalakshmi and Daniel ma'am for giving us this opportunity and teaching us about the simulation and clearing our doubts. And I would also like to thank my teammates Ujjwal and Veda for making this easy project and simulation process. Thank you guys.